Alright, let's continue objective 2 about using the graphing calculator to find, to make a scatter plot and find a line of best fit. So in the previous video, what we did is we just did a scatter plot. We saw that it had a strong positive correlation. So if your set of data has a strong correlation, then that of course means that the correlation coefficient is pretty close to 1, then you can have the calculator to come up with a line of best fit. It's a trend line that reasonably models the data. Okay, again, that's called the line of best fit, and it's as close to the points as possible with, as many above as below. So let's take a second to see what this looks like as a least squares regression line on Geometry Sketchpad. Okay, so in this Sketchpad demo, what I have is a set of data, and the data consists of point 1, 2, 3, 4, 5, and 6. Okay, and this purple line here is the least squares regression line. Its distance from each one of the points is measured by this dotted red line, and that's called a residual in statistics. Okay, so as I've said before, that distance, if it's above the line, it can be positive, and down below the line it might be negative, or vice versa. So instead what we do is we usually square those distances, and now the number is positive. And if I take all of those purple squares and I take their areas and I add them all up, I get the sum of all their squares. Right now the sum of all of those purple squares is 8.2 square centimeters. Okay. And this line would change, or that big square would change, depending on where I put it. Okay? And so the job of the calculator is to figure out where best to put that line so that that square is as small as possible. Okay? And that would be the least squares regression line. If you do take statistics, you will learn how to do this by hand. But for us, we're just going to do it on our graphing calculator. Alright, very interesting. Maybe you'll see something like that again in your life. Okay, so this is the same set of data that we were working on in the previous exercise. Let's find the best fitting line for that data, because it had a pretty strong correlation coefficient. Now, and in the rest of the slideshow, again, there's all of these steps on how you're supposed to find that least squares regression line. Geez, it's pretty long. So again, you might want to write something down, or you might want to go back to that slideshow and actually print those instructions off. Okay, so in the meantime, let's call up this calculator here, and turn it on, and on. There's my scatter plot. Looks fantastic. Okay, so now how am I going to get the line for that? Okay. So the line is again under the Stat menu. So let's hit the Stat button, which is on the second row, last button. This time I'm going to scroll over to Calculate menu, C-A-L-C, and we're looking for a linear regression. In statistics, if you have a set of data and you're trying to model it with a line, or maybe a parabola, or if it's exponential, it's called a regression. So this is called a LIN, linear regression. You could see it's AX plus B. It's number 4 there. So that's the one I'm going to select. Okay, on this new operating system, it puts a nice little menu for you to select all of the options that you want it to calculate from. So the X list is coming from L1, the Y list is coming from L2. You don't have to worry about this frequency list, but you do want to store your regression equation as Y1. That's so that it graphs it for you whenever you hit the graph button. So to find Y1, it's underneath the Vars menu. Look right beside clear. It's on, this time it's on the third row. Next to the last button it says Vars. Hit that button. You have across the top Vars and you have Y Vars. Well, this is Y1 that I'm looking for, so I'm going to scroll over to Y Vars. Now look at the options. Which is the only one that to you probably makes any sense? It's number 1, function. So underneath that menu, look at it. There's Y1. So I'm going to hit enter here, and that's where it's going to store it. And now I'm going to turn on calculate. And it gave me my y equals mx plus b. It gave me a as the slope. It gave me b as the y-intercept. I don't have to, like if I'm on a quiz, I might want to write something down right here, round off the numbers or whatever. But I don't have to type it back under y equals because I had it stored in there for me. So it's automatically in there. And if I hit graph, there it is. And you can see it does a really good job of going straight through the middle of all that data. Now, one thing that I didn't do here is I didn't turn on diagnostics. If I turn on diagnostics and I do the computation, it will compute the R value for us. So let's see what that is. So let's quit back to the main menu and let's turn on diagnostics. The only way to get to it is underneath the catalog menu. So catalog is right above 0, down at the very bottom, and it's in blue. So it's second 0. And now this is in alphabetical order, so just type in on the keyboard a D for diagnostic. So if I just hit a D, and then I start scrolling down, and I'm looking for diagnostic on. So I have diagnostic off, the next one is diagnostic on, hit enter, pulls it to the home screen, hit enter one more time, and it'll say done. It doesn't look like it did anything. So let me call back up what we typed in before to calculate the least squares regression line. You don't have to type anything else in again. You just hit second, enter. Well, that was the last thing that was typed in. So let's do it again. Second, enter, and that's the regression line that I typed in before. Now if I hit enter, it gives me down at the very bottom the correlation coefficient, and look how close to 1 it is. It's 0.9929 blah 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 blah. It's very, very close to the number 1, indicating that it's a very strong positive correlation. Okay, so again, here are all the steps involved in doing all of that stuff. And then oh wait, if I go back to this, does it want me to predict something? No, it didn't, not yet. But I'm going to make a prediction right here. Use your line of best fit to predict the number of alternative fuel vehicles in use in the United States 14 years after 1997. So this is the whole reason why people would want to find some kind of regression model, a best fitting line, so that they could make a prediction of something that's outside of their data. Okay, so I'm just going to plug 14 into my equation, and there's a pretty easy way to do that on the calculator. So I'm back on the home screen here. If I just type in y1 and put in parentheses 14, it'll calculate it for me because y1 is stored into the calculator. Here's another way to get y1 if you have the calculator with a newer operating system. Hit alpha and then F4, and there's a list of them right there. It's the first one. Hit enter. Now I'm going to put in parentheses, it's kind of like function notation. In the parentheses put 14, close those parentheses, hit enter, and I can see it's 835, but this is in thousands, so 835,000. Okay, so now it is your chance to see if you, practice a little bit, entering the data, finding the best fit line, finding the scatter plot, and all that stuff. The table below gives the systolic blood pressure Y of patients X years old. Determine if a correlation exists, and if a strong correlation exists, find the line of best fit. Predict the systolic blood pressure of a 16-year-old. So put this data in your calculator, do a scatter plot. Oh, does it have a correlation? Okay, find the line of best fit, and once you do, plug 16 in there, and let's see what your prediction is. Alright, I hope that you were able to keep all those steps straight. Let's see if we came up with the same answer. So, about to hit calculate on here. Here's my regression line. My slope turns out to be about 0.96. My y-intercept 81.05 if I round it. And I can see my correlation coefficient not quite as strong as the previous one. It's 0.8966, but still it's pretty close to 1. So it's still a strong correlation. So Since I went ahead and stored that as y1, I hit graph. There's my least squares regression line. Does a pretty good job going straight through the middle of all that data. And now it wanted to know what would be my prediction of the systolic blood pressure of a 16-year-old. So again, let's do that in function notation. Pull y1 up in the calculator, in parentheses put 16, close those parentheses, and we get about 96. 96. Let's see. So your model gives about 96, but according to the internet, if the internet is to be believed, a 16-year-old's blood pressure, if you're a girl, is between 122 and 132, and boys 125 to 138. So in other words, our model predicted something that, I don't know, would lead to somebody's death. Okay, so the question is why was it so far off? Why was it so wrong? Let's look back at this. What we have are the ages of from 43 to 70. Now, if I'm measuring the blood pressure of some older people, do you think that that's going to relate to a 16-year-old? It's a very good question. And this is a problem in statistics that's called extrapolation. So because our prediction was based off of those older people, it was so far off of the range that our answer couldn't really be relied on. Okay? So that's something else to keep in mind. The further away that you get from your set of data, well, the less reliable your prediction is going to be. Okay? So that concludes our lesson on direct variation, modeling direct variation. Remember, that's y equals a times x, where a is the constant of variation, and using the graphing calculator to draw scatter plots and best fitting lines. And here I'll leave you with this cartoon. If you can't read it, it says a man's handsomeness is directly proportional to the size of his chin cleft. Well, on the left you got a guy that's pretty handsome because he's got a cleft chin, and then the hottest guy over there on the right hand side with that butt chin. Okay, so here is your homework assignment with some words of wisdom from Rowan.